this recent landslide, which is a very typical natural hazard, and which occurred in western Sichuan in year of 2017. Yeah, I will take it as an example how to analyze the mechanism of geohazard or landslide in terms of geology and geomorphology, which is an important research direction in engineering geology. And hopefully you can get something about how to tell a scientific story on this field. Although you have many uh, uncommon vocabulary for you. Okay, let me start. The Shimo landslide in western Sichuan occurred on June 24th in the year of 2017 in the Songpinggo River, which is a tributary of the upstream Minjiang River in southwestern Sichuan. Southwestern of China. And this is the high-speed rock avalanche disaster occurred in the morning and caused a very severe damage on human beings, and which buried the whole Shimo village, resulting in about 100 casualties. So yes, about 100 people were killed or missing during this destructive hazard. And the region between the Tibeto and Sichuan Basin, this kind of transitional region is characterized by Nomanshan fault, consisting of three minor faults. And elevation rises from, like I said yesterday, the 600 meter in the Sichuan Basin to the peak exceeding 5,500 meters over a horizontal distance of tens of kilometers. And the steep topographic margin was established by the rapid orogenic uplift, which resulted in intense river eroding into a plateau surface and formed high relief valleys, and that may frequently lead to large landslide. So Minjiang Basin is a good region to study the issue that how the hillslope process responds to the fluvial incision. And the region where this landslide occurred is eastern margin of the Tibetan Plateau is characterized by deep valleys due to the intense river incision caused by strong neotectonic activities, and it is quite adjacent to the trunk river of Minjiang that flows from north to south. And such a high relief topography may control the stress field within slopes and may induce the gravitational slope deformation, which we commonly observed in this area. And we know gravitational slope deformation creates a number of geological structures which destabilize slopes to prepare for catastrophic failure during earthquakes or rainfalls. And there are a number of prehistoric landslides in this area, most of which seem to be rock avalanches. So there must be some relationships between catastrophic rock avalanches and deep-seated gravitational slope deformations. And the Simo landslide could provide a very good case example to clarify this issue. So the purpose of this study are to characterize geological and geomorphological features of the 2017 Shimon landslide. And to demonstrate that the gravitational deformation occurred before the landslide, and finally discuss about the role of gravitational slope deformation for the landslide, and to discuss the prediction of potential catastrophic landslides, focusing on some other unstable hill slopes nearby the Shimon landslide in the Songpingo River catchment. And the methods of this study includes field service, interpretation of area image, topographic investigation, and discontinuity analysis by software called 3D. So this type is used to for show for showing you what story could tell, like in a scientific way. So we have been studying the old landslides in the Songpingo River. Yeah, at least 1 year before the occurrence of this new landslide. And this is a landslide inventory that we made before the new landslide by stereoscopic observation on remote sensing images. The same landslides were aligned on the major river of the Songpingo, and their landslide bodies used to block the river distributed in the segment about 8 kilometers from the confluence at DH site. This is DH site. It is another gigantic landslide, and which I will talk in our later chapters. And Shimon landslide. Shimon village was located on the very bottom of this river, and based on our interpretation, we clarified that the village was on the deposit from a previous large landslide before the 2017 event. And we recognized a steep and planar slope near the ridge top, and a lobate convex slope from its bottom to the valley bottom, and which are generally interpreted as a previous old landslide, which is presented in this figure. And the relative elevation from the riverbed to the top of the previous landslide was up to, you can see, over 1,600 meters. And fan-like deposits were made to the very bottom and extended about 2 kilometers downstream from the foot of the slope. And the new landslide in 2017 occurred on the right on the scarp of this previous landslide. And comparing the topographies taken before and after the event, we recognize that the new Shimon landslide started on the south-facing slope along the western portion of the previous landslide scarp. And we can see the source area of the new landslide was rather small from the whole landslide area, and reported a volume rock mass from the source area rapidly hit the previous landslide deposit and remobilized them, and finally generated a much larger landslide area like this, and finally buried the village. It could be attributed to the energy of the rock mass that rushed down from the 1,000 higher source area. And first, I will talk about what we observed before the event. We investigated an outcrop of alternating beds of sandstone and some pelagic sheets, which is just to the west of the Shimon landslide, and many holes distributed on the outcrop, which were made by the dissolution and removal of calcareous material, and the bedding plans trends near east-west and 48 dips to the south. Maybe you are not familiar with this such a symbol, and maybe it is okay. I will teach you in our later class. Here you just understand the general mechanism of this landslide. So moreover, the beds near the top near the slope surface were slightly buckled to have a convex hinge below which were steeper beds. Unfortunately, we have observed the source area before the landslide event. And the scarp of the previous landslide, which involved the source area of 2017 landslide, had exhibited the typical features of gravitational slope deformation before the event. We can see a number of subhorizontal fractures on the planar rock surface were observed on the head scarp above the deposit. And buckle fold, this is buckle fold hinge, can be clearly seen on the surface of source area. And the attitude analysis by Cotop 3D based on the DEM data was made, which indicates that the planar rock surface was parallel to the bedding attitude. And these are what we got before the Shimon landslide. So maybe after the class about the natural hazards, you can understand why we call it a very typical symbol of gravitational deformation like this. And the detailed geological structure were observed and interpreted after the event from the source area. And the source area is bounded by a steep cliff with a height of 30 to 40 meter on its right back. On the the west back of this landslide, which was along a high angle joint, which trends northeast to southwest, and the surface of the cliff was iron stained and brownish, which suggests that it had been already open for a time before the new landslide occurrence. And some subhorizontal open fractures along the axial part of buckle folds were observed on the sliding surface, and which looks rather brittle. There are also some fractures striking along the high angle joint, and nearly horizontal linear bulge due to the buckled folds were observed on the convex bedrock on the west of the cliff, and the opening at the bulges were also pronounced. Above all, the source area of the new landslide, rather small from the whole landslide body, had been the gravitationally deformed portion located on the steep slope of the alternating beds. In addition, the aerial photographs and satellite images are also helpful to identify the deformations. And these images were taken by Google Earth, and you can easily check it on the Google Earth freely. So on the rock surface just below the ridge top, before the landslide, we can see a bulge with horizontal trend, and the rock surface was planar and parallel to the bedding. So the bowl should be the actual part of the backfold. We also clearly identified three cracks. You can see running oblique to the slope direction before the event, and the location of crack one exactly coincided with the cliff that bounded the western margin of the source area, and the crack three corresponded to the eastern border of the landslide. So as I said, the crack one probably had opened before the landslide, before the cliff surface, yeah, exposed after the event, show an impressive brownish color, which should made by its interaction with air by oxidation. Uh, yeah, a kind of chemical processes. And these facts further suggest that the rock mass between the crack 1 and crack 3 had been already deformed to form the buckle fold before the event. And after that, I made some calculation. Here I will skip the details. And besides, it's reported that 1 week prior to the Shimonen site, persistent rainfall for 8 days probably infiltrated into the rock mass along joints and the fractures that were formed by gravitational slope deformation. A simplified model proposed by Professor Cruden was used to evaluate the stability of flexural buckling of plan steps. And the results suggest that the buckle length of the Shimosource area could easily fail within such a laminated rock type in a thickness of maybe about 1 meter. And as a result, for the Shimonen the persistent uh, rainfall probably dominated the groundwater drainage and finally triggered the catastrophic rock avalanche under the context of the decreasing uh, of strength and tensile strength. And braidal fractures and backfolds were made by slope deformations, which still remained on the sliding surface, as I talked just now. After that, we focused on the hill slopes nearby the Shimon landslide. And this is landslide adjacent to the river mouth, which used to block the stream. After the landslide deposit, very pronounced brittle open fractures and buckle folds developed on the headscarp. You can see here. And it indicates that this landslide should be also preceded by a buckling deformation. And we can see this phenomenon is quite similar to the headscarp of the Shimo landslide. So it further implies that the Shimo landslide had been suffering the buckling deformation prior to the event. Then we move to the hill slope on the east side of the Shimo landslide, which was not has not slid yet by now. And we can see this slope is smoothly curved with a gentler slope on the upper portion and a steeper slope on the lower portion. And open fractures, open cracks under the structures are developed on the lower portion of this slope. So we could ask, can the potential sites of landslide be known beforehand? The answer is that structural observation might be a way. So according to the interpretation, we identified some buckling deformation with a sub-horizontal hinge on the middle part of the slope, like those structures we observed in the source area of the Shimonet slide. And the buckling deformation also forms a A-10 structure with voids underneath on the lower steeper portion of the slope. And such a detailed field observation should be helpful to obtain information about the potential landslide site, especially that evolve from gravitational slope deformation. Therefore, firstly, the abnormal landform indicates that this slope could be attributable to the gravitational slope deformation. And the warping on the middle portion of the slope and the remarkable A-tent-like open cracks on the lower steep proportion further suggest that this hill slope were made by deformation of buckling. The topographic features and geologic structure strongly indicates that this hill slope could fail and evolve to a catastrophic landslide induced by some further earthquake or rainfall events. So above all, we could draw the conclusion, which is that the firstly, the Plato open fractures and buckle folds on the bedding planes in the source area before and after the landslide indicates that the dominant gravitational slope deformation buckling had preceded the Shimo rock avalanche occurred in the year of 2017. And secondly, the infiltration of persistent rainfall in the fractures made by pre-existing gravitational slope deformation probably dominated the drainage of groundwater and finally triggered the catastrophic rock avalanche under the decreasing of shear strength and tensile strength. And moreover, the hill slopes on the east of Shimonet slide exhibits well-developed open fractures and warpings by buckling, which strongly suggests that the hill slope is unstable and could fail by a future intense rainfall and earthquake events. Okay, this is something about the landslide case study uh, in my previous study area during my doctoral course. And next I can tell you something more about the landslides induced by the 2008 Wenchuan earthquake in Sichuan, China. Yeah, you know this Wenchuan earthquake which is very famous one that was induced by the celebrated Norman fault. So yeah, I hope you can obtain some ideas via uh, listening to this study. So in this study, this study was conducted actually by my Japanese supervisor around 2010. Uh, yeah, yeah, precisely I was in the grade 2 of my undergraduate course, and I got a very good opportunity to follow my future Japanese supervisor to the Wenchuan and to implement a very interesting field survey and finally, our work were published by a very good, famous journal, Geomorphology. So, firstly, we used speaking of the method, firstly, we used the satellite images taken by the ALOS of the uh, yes, aerial product provided by the Japan Aerospace Exploration Agency after the earthquake, and to interpret. In order to interpret the distribution of landslides in the affected areas, and the satellite images were taken by a satellite sensor with a resolution of 10 meter and a prism sensor with a resolution of 2.5 meter. And we also use satellite images taken before and after the earthquake and provided by Google Earth. And most of the former images were taken by spot of French satellite and have a resolution of 3 meters. And the Google Earth images include height information, so thus approximate length and elevation measurements could be made through this. And the interpretation of internet satellite images were complemented by a 3-week field investigation. So let me start about this study. So as I told before, the debates. Firstly, I will need to address the introduction and the background of the study area. The Tibet Plateau is a major topographical expression of the ongoing collision between the India plate and the Eurasian plate. You remember that, okay? Right? And the question of when the Tibet Plateau attained its current elevation and how rapidly it became like this is still at the forefront of debate as one of the first order problems of continental tectonics. And such a study issue were well has been studied by many tectonics experts, but uh, major uh, our major task is that evaluating the some geologic condition for engineering. So our uh, purpose is different. So as I talked before, the eastern margin of the Tibet Plateau is one of the most remarkable escarpment in the world. And this is an extraction of topography along different directions of Tibet Plateau. And we can clearly see that although the profile C and profile D are located along the east of the Tibet Plateau, but they show very low topographic gradient, you see. And notably, the for the northern portion, southern and the east margin near Sichuan. This is Sichuan Basin, you see, which is concave geometry. And they are characterized by very steep topographic gradients. And the eastern margin adjacent to Sichuan Basin is what we are really interested in. It's near the closest one to us. And the structure of the Longmenshan mountain is characterized by northeast trading thrust lab belt with a length of approximately 500 kilometers and is composed of three major northeast striking thrust faults: the Maowen fault, the Yingxiu Beichuan fault, and the Guanshan Anshan fault. And the middle one, the initial Beichuan fault, was the one which generates the 2008 Wenchuan earthquake. And this is a detailed topography along the east margin of the plateau. And the diagram were described in a 100-kilometer wide uh, rectangular, and in which projected onto a vertical plane located at the midline of the cross section, as shown as a maximum elevations, mean elevations, and minimum elevations. And it is impressive that the surface of the plateau north and east and west of the escarpment stands at elevations between 3,500 and 1,400 meter, and is characterized by extremely low local relief for the upstream portion, and it has been pointed out that the eastern margin of the plateau, Tibetan Plateau, adjacent to Sichuan Basin, appears to be a erosional escarpment formed in response to uh, development of regional elevation gradients between the plateau and the Sichuan Basin. So I have introduced some reasons why such a topography was formed before. Uh, yeah, I believe you got the impression that at first the Tibetan Plateau uplifted and the hydraulic gradient increased, and which resulted in very intense river incision. So such a high mountain and deep valley of mm, such a topographic features are formed, and which is like this today. And the Wenchuan earthquake occurred at 2 o'clock and 28 p.m. at local time on May 12th in the year of 2008, and near the west edge of the Sichuan Basin in China. And this earthquake had a magnitude of 7.9 and a focal depth of 19 kilometers at in the Western Strait. So an outstanding characteristic of this earthquake is that it was accompanied by fault ruptures over a distance of about 270 kilometers. And thus, the affected area, which is temporarily defined as the area with landslide induced by the earthquake, it was far larger than that of recent earthquakes in mountainous areas, such as the Qishu earthquake, which happened in the year of 1999 in Taiwan, and the 2004 Niigata prefecture earthquake in Japan, and the 2005 northern Pakistan earthquake. Yeah, the Wenchuan earthquake is far larger than above recent earthquake. So large number of earthquakes were induced during the earthquake, and the rocks of the mountainous areas range from Precambrian to Cretaceous uh, in age, and consist mainly of basalt, granite, phenite, dolomite, limestone, sandstone, and shale, and some other types of rocks. And as I mentioned, The Normanshan fault zone comprises three main faults, and some previous studies documented that major ruptures along the initial Bechuan fault and minor ruptures along the Guanshan-Anshan fault, and the low ruptures were found along the Maowen fault, uh, which is the most northwest fault. And we identified fault ruptures along the initial Bechuan fault over a distance of 180 kilometers from west of Dujiangyan to northeast of Pingdong. And most of them trained northeast, but some trained northwest or north, and along the northeast trending ruptures, it was reported that the northwest side, which is the hanging wall, uh, you remember what is hanging wall? Hanging wall and footwall, right? And the northwest side is the hanging wall, and which rose up to 11, about 11 meter with right lateral displacements of up to 12 meter. It's really amazing earthquake. And this figure presents a distribution of landslides induced 2008 winter earthquake in the study area nearby the Normanshire Fault. And according to the statistical analysis, it is found that there are about 13,000 landslides with a total area of about 418 square kilometer. And it indicates that the landslides are distributed primarily along the causative faults of initial Beichuan fault and Guanshan-Anshan fault. Yeah, the middle one and the southeast one. And landslides triggered by the earthquake include a large number of shallow and deep-seated rock slides, rock falls, debris slides, and debris flows. And the shallow landslides were the most common and occurred on convex slopes or ridge tops. And before I start the detailed landslide topic, I need to address the major types of hill slope due to the different orientation between rock rock discontinuity and slope. And there are two major slope type according to the rock discontinuities and the slope surface. And in category of slopes, the penetrative discontinuities dips in the same direction as the slope. And in anaclinal slopes, the penetrative discontinuity dips in the direction opposite to the slope. You see? And conventionally, these descriptive terms can be limited to slopes whose strikes or azimuths are within 20 degree of that of the penetrative discontinuity. And categorical slopes may be further divided into three subtypes: overdeep slopes, which are steeper. Oh, sorry. Overdeep slopes, which are steeper than the depth of the discontinuity. Underdeep slopes, which are less deep than the depth of the discontinuity. And deep slope, which follow the rock discontinuity. And anaclinal slopes, which are perpendicular to the dip of the discontinuity are called normal escarpments, and slopes steeper and normal steepened escarpments, and the slope less steep than normal subdued escarpments. And these are some typical failure according to different types of slope. And the most classic ones we commonly observe in the field are buckling, which discontinuity like this, but it usually occurred in the cataclysal slope, and toppling, which commonly occurred in the high angle discontinuity slope or anaclydal slope. And in some cases, the toppling can also occur in the very in a cataclysal slope, which with a very steep angle of discontinuity. And this belong to the gravitational slope deformation, which is the pre-landsliding features. So it could occur and has been developing before the landslide, maybe for uh, years or even for some hundreds of years, and uh, it's not easy to know the exact time when it will occur the landsliding, but it has been deforming. So we can know the potential landslide size through such features beforehand, uh, for which I have introduced the simple landslides in this area, which is uh, which was my one of my major previous studies, and I have published it on the engineering geology of the Journal of Engineering Geology. You remember that? So plenty of landslides happened during this earthquake. We really call it co-seismic landslide. And what is notable is that the failures of such isolated ridgetops where earthquake shaking was really amplified. So slopes composed of carbonate or granite rocks had the highest uh, failure rate. And these rocks are generally hard, but the surface and near surface rock mass is fragmented, and the blocks apparently collided and repelled each other, causing them to detach from the slopes. And the alternate beds of sandstone and mudstone of the Triassic age failed on many slopes near the fault traces, including inshore near the epicenter. And many rockfalls occurred on cliffs which had terrace on their feet. Terrace is the term describe with, that describe the colluvial deposits just below the some very steep cliffs, and the fallen rocks tumbled down and were usually caught within the terrace surface. And terrace generally developed by the kind of process which supports our observation about the fallen rocks. And a relatively large landslide occurred on slopes with cap rock structures, in which competent carbonate rocks or sandstone overnight relatively incompetent shale or finite. And the localization of these large rock slope failures suggests that the seismic wave amplitude increased at the ridge tops. And secondly, many rock slides occurred on carbonate rocks, principally dolomitic limestone and limestone. And some rock samples have been examined using the X-ray diffraction methods in our Japanese laboratory. And the carbonate rocks are mainly micritic and not spalitic, sandy or muddy. And they are generally well stratified and partly densely jointed. And deep-seated rock slides in carbonate rocks commonly occurred on cataclysmal slopes, and shallow rock slides and rock slides occurred in carbonate rock occurred on alkylino slopes. And alkylino slopes are generally steeper than calcalino slopes. I think it's easy to understand, and so they are uh, susceptible to shaking induced failure. And moreover, dissolution of carbonate rocks. You remember the composition of carbonate rocks, like limestone? Yeah, the calcite, like it's very one of the major mineral which form the carbonate rocks. And so dissolution of this mineral in the carbonate rock by groundwater created some open cracks and decreased the contact surface along the bedding planes. You see this schematic. And many of the sliding surfaces in carbonate rocks had rough surfaces with dimple-like depressions by dissolution. You can see in the photographs and this schematic. And shear or tension resistance along this surface is lower than that along surfaces where solution has not occurred. And the earthquake shaking broke the contacts and inducing the catastrophic slope failure. A rock slide that entered Beichuan and killed 700 people was in carbonate rock and presumably occurred along a bedding parallel steady surface like this. And the Xiaojiaqiao landslides were located about 34 kilometers northeast of Dujiangye, occurred with a slimy surface along a bedding parallel fault with a stick side and a gouge with a few centimeters thickness in carbonate rock. And a large landslide called a large landslide located west of Beichuan occurred on a gravitational deformed slope of weathered shale. And it was an alkylino slope, which has been deformed by mass rock scrape of the toppling type. And rainfall following the earthquake washed down the residual weathered materials and the landslide deposits on this slope to form debris flow and enlarging the damaged area in Beichuan after the earthquake. And the Tangjiashan landslide in Beichuan produced the largest landslide dam in the affected area, and it also caused the most hazardous situation during this after the earthquake because it blocked the river and uh, and stored a very tremendous volume of water. And the Tangjasin Nesla Dam is located about 5 kilometers upstream of the town of Beichuan, which was completely devastated by the wind earthquake and the large uh, seismic landslides. The landslide broke the Tonko River with an upstream catchment area of uh, over 3,500 square kilometer. And the Tanjashan National Dam was formed by a rock slide in fragmented bedrock composed of siltstone, siliceous rocks, and mudstone from the lower Cambrian, the age of Cambrian. The bedrock was covered by a colluvium with a dense vegetation. The landslide is located on the hanging wall of the major fault, uh, Inshou Beichuan Fault, and only 2 kilometers away from surface fault rupture. It occurred on a deep slope of shale and slate, like shown in this sketch, and this photograph shows the landslide deposits just at the foot of the slope, and the lower right sketch shows the reconstructed uh, geologic structure before the landslide. So, can you recognize this? What this failure type is? The geologic structures observed on the site flags of the landslide indicate that the beds had been buckled gravitationally beforehand, and the sliding surface was made along the bedding plane and joined parallel to the slope surface. So it's a very typical buckling failure. And the spot image on Google Earth indicate that this landslide occurred on a slope with a spur crossing depression in the upper portion with upslope convex traces. And this topography also indicates that the slope had been deformed by slow rock creep before the earthquake. And ALOS image, uh, yeah. Furthermore, the ALOS images indicate that some landslides have long lobate forms, suggesting that they occurred by flow. And a notable example is the Shijiadian landslide, this one, and which occurred across the probable fault rupture, and it was 1.5 kilometer long and up to 250 wide, and the apparent angle, friction angle, is about 22 degree. And the hillscarp of this landslide is on a steep cliff of Precambrian granite, which is located above a small valley that channeled the flow. The volume of the filled rock mass is much less than the volume of the deposit. We found that the bedrock in the valley below the cliff is overlain by bluish gray water saturated clay debris, which had formed before the landslide and in turn was covered by the landslide deposit, consisting of water saturated brownish debris with rubble. And there were wrinkles, streaks of rock fragments of the same colors, and streaks of soil clots on the surfaces of the landslide deposits. And these features are commonly observed in rock avalanches. A cross section through the landslide debris near its distal and revealed a reverse grading, in which larger blocks up to 5 meters across are concentrated in the surface, and the smaller grayish material is underneath it, the surface. And this characteristic strongly suggests that the very few sediments were mobilized by pore pressure buildup or liquefaction and flowed down the valley. And loading by landslide debris from above may have played a role in initiating the movement of the valley field. Similar non-lopate landslides in valley bottoms were induced in more than 34 locations by the 2004 Niigata Prefecture and earthquakes in Japan, which occurred after about 100 millimeter precipitation during the preceding 2 days, which was investigated by my yeah, Japanese supervisor. And they were uh, the landslides were also attributed to pore pressure buildup or liquefaction in wetfield materials, and the possible liquefaction was supported by muddy set blows observed on landslide deposits. And actually, we did not observe set blows on the deposits of the Shijiadian landslide, but it had water saturated clay materials in its base, and the movement was slow. This indicates that the pore pressure buildup and possibly liquefaction could have occurred. And land-based landslides similar to this Shijiadian landslide were at about 35 other locations from the ALOS satellite image observation. And they ranged in length from 600 meter to 28 and 30 meters, and had an average length of 1.2 kilometer. Okay, furthermore, a very large landslide was detected on the image of the ALOS satellite on June 6, June 4th. And this, it is called Daguanbao landslide, which is one of the uh, most gigantic landslide even in the world. You can easily find the many papers about the Daguanbao landslides in the from internet. And this Daguanbao landslide occurred in mountains 2 kilometers northwest of the trace of the fort near Chimping, and the area of the landslide based on measurements made from the ALOS prism image is about the area is about 2.3 square kilometer, and its volume is estimated to be about uh, 0.8 uh, cubic kilometer. And based on the comparison of the prism data and the SRTMD and the examination of the ALOS and the spot image taken before the landslide, indicated that the headscarp of the landslide was a 2 kilometer long ridgetop linear depression with an open V shape in plan view. So as I talked this before, the linear depression is a very classical topographic feature of the uh, gravitational slope deformation before the landsliding. You remember? Okay, so this type of landform is indicative of a slow gravitational deformation. So similar V-shaped linear depression were found at the site of Caolin slide, which was triggered by the Chicha's quake in uh, Taiwan 20 years ago. And the Daguomo landslide was of faded dolomite with subordinate shale, and the thickness of the dolomite beds varied a few tens of centimeters to 10 meters, and shale from several centimeters to meters, and bedding plan deep to loss at 35 degree. And the direction of the landslide traveled was to uh, ENE, oblique to the it is oblique to the deep direction of the bed. And as shown in the topographic map made from a prism image, the southern half of the landslide scar was a planar bending surface, and which bulged upward and showed a convex profile, which is located here. And this upward bulging accompanied fracturing of the beds and probably indicated that the buckling of typical buckling of beds occurred. And a similar buckling were observed at the Chufeng Ershan landslide triggered by the Chichi earthquake. And this probable buckling may be the mechanism by which the southern part of the ridgetop depression mentioned just now. And the headscarp of the Dagonbao landslide was along a fault, you see, and trains NNE and dips uh, about remember 75 to ESE towards the ESE. And the northern half of the linear depressions was along this fault, you see, and suggesting that the previous movement occurred along the fault. And the second largest landslide, the Yinpingo slide, occurred on a slope of carbonated rock 4 kilometers southeast of the infer trace of the fault near Qingping. And it is 4 kilometers long and 1 kilometer wide, with an area of 3 square kilometer. And the landslide scar is a west-facing deep slope with a smooth planar surface. The field rock traveled down along a valley and super elevated at the outer sides of the valley base, suggestive of debris avalanche. This landslide occurred on a smooth surface without gullies, suggesting that there was a barely surface runoff, and probably due to the high permeability of the bedrock. And the slope showed no evidence of pre earthquake gravitational slope formation, but it was undercut and a probable reduction of shear resistance of by rock dissolution, rock dissolution by groundwater or surface water, and undercutting the slope are likely the main causes of the landslide. And many surfaces of blocks in the landslide debris show evidence of dissolution. You can see it. And most of the yeah, let's move to the regional landslide distribution and fault rupture. And most of the landslides were concentrated in two areas we can see in this figure. Firstly, they are near the fault that generated the earthquakes, which is the Beichuan initial Beichuan fault. And the other one is the other features is that they occurred on the steep slopes adjacent to the Minjiang River. So two major factors. One is about the tectonics, about and uh, seismic seismic shaking, and the other one is the topographic features like the steep slope. And the landslides occurred over a distance of more than 2,070 kilometers along the Longshan Fault. And the maximum width of the landslide zone is about 30 kilometers. And the distribution area is broader near the middle and southern parts, southwest parts of the fault zone, and narrower towards the northeastern end. And the distribution area is sorry, and the concentrations of landslides, except for the steep slopes along the Minjiang River, the concentrations, the landslide concentrations coincide approximately with the area of Chinese seismic intensity level or larger, and the steep slopes along the Minjiang River from Yinshou to Maoshan, which is the northeast part of the middle fault, experienced numerous landslides and seem to be within the area of Chinese seismic intensity line. And in contrast, the northwest half of the mountains between the Minjiang River from Wenchuan to Maoshan and the areas around the initial Beichuan Fault trace had far fewer landslides, which is located here. It's far there is far fewer landslides here, and in some earthquakes, the density of landslide is closely related to epicentral distance. But the landslide distribution of the Wenchuan earthquake is more of a function of the distance from surface fault ruptures and by the distribution of the valleys as discussed below. And in the northeastern area, landslides were concentrated on the hanging wall. You see, yeah, this part is hanging wall and this is footwall. And the most landslides were concentrated on the hanging wall of the initial Beichuan fault. And within a few kilometers of its rupture trace, and the area ratio of landslides to the whole ground is as high as 6% within 5 kilometers of the rupture on the hanging wall, but decreases to 0.2% over the next kilometer. And the ridgetop failures were scattered outside of this zone. And far fewer landslides occurred on the footwall of the fault. You can see in these two diagrams. And there was also a marked contrast in the damage to houses between the hanging and the footwalls at Pingdong. Houses on the hanging wall were completely destroyed, whereas those on the houses on the footwall suffered only minor damage. The bedrock on both sides of the rock is the same, which are weathered phenites with northwest dipping foliation. So the situations in hanging wall and footwall is so different. And between Pingdong and Beichuan, the fault trace is curved, you see, and the area is a zone of compression because the fault has a right natural sense of displacement. A large number of landslides occurred in this area and over a wide area. A large landslides southwest of Beichuan were mapped using the Avenir 2 image instead of the prism image. And the area of landslides broadened from Beichuan to Hongbai. And between Xiaojiaqiao and Hongbai, landslides occurred on the hanging wall within 15 kilometers of the trace of the initial Beichuan fault and on the footwall within 13 kilometers of the fault trace. And however, in this area, the footwall of the initial Beichuan fault is the hanging wall of the Guanxian ancient fault. Can you understand? The footwall of the middle fault is the hanging wall of the southeastern fault. And the dominant bedrock in this area is dolomitic limestone and limestone. And about the landslide size, the landslide size frequency relationship is similar to the relationship between the earthquake frequency and the magnitude. And the cumulative number area relation of landslides identified using satellite images with a resolution of 10 meter can be described by this equation, and where the n is the cumulative number of landslides larger than or equal to x, and a is the a this part is the area of landslide, and A and B is constants. And landslides, we can see landslides smaller than from the FDR to data. The landslide smaller than 200,000 square meter deviated from the line defined by this equation, and suggesting the incomplete sampling of small landslides on the FDR2 images. And this figure also indicates that the two largest landslides in Xingou and Daguangbao landslides deviation from this line. Such a condition commonly happens in many areas in the world. And the relationship between landslide number and size for the area near Pingdong was analyzed more closely using the prism with a higher resolution, and we about 2.5 meter. And we can see the linear part of the curve is parallel to the two areas of landslides, and obtained from the different data. But the line from the prism image, it lies to the left of the avenue data, and this result indicates that the landslide near Pingdong were smaller than those of the central to southwestern part of the affected area, and the parallelism of the two linear parts of the curves from both areas maybe because the same earthquake induced all the landslides. So you got the point? Yeah, the parallel lines, why they were parallel? Because it might be because they were induced by a single earthquake event, the Wencha earthquake. And the movement directions of landslide identified on the Avenir 2 images are shown here. And the landslide have preferred orientation dominated by uh, WNW to ESE to northeast to northwest to southeast directions, and these directions are approximately normal to ruptures traces of rupture propagation direction of the Wenchuan, 英秀北川 and Anxian uh, faults. So the movement direction is perpendicular to the major faults. And it suggests that directivity effect of the seismic wave. And it was reported that the earthquake-induced landslides are dominantly oriented away from the epicenter due to the behavior of those seismic waves within a mountain. And the propagation direction of a seismic wave during the Wencha earthquake was to northeast, but fewer landslides moved to northeast than toward northwest to southeast. We were unable to analyze the directions of all slopes, including landslide slopes, because of the lack of higher resolution DEM data corresponding to the Avenir 2 image. But we observe many ridges trending northwest to southeast with northeast or southwest facing slopes in the affected area. And this indicates that the preferred orientations of landslides stated above are not due to the slope directions. And the moving directions of the landslide could also be affected by the bedding attitude, of which we have not enough data by now. Maybe our next working our next stage, we can complete complemented complement such a data. And however, the geologic structures in this area is rather complex with faults and thrust. So we suppose that the above preferred this preferred orientations of landslide movement is more affected by seismic waves rather than the geologic structures. And besides, relatively shallow landslides were concentrated on steep slopes in the valley of the Minjiang River from Yingxiu to Baoxian. And these slopes, this river segment, and these slopes are the inner gorges, or we call it inner valleys, reported by Kisley in 1988, and it can be clearly seen in the satellite image you see the inner gorge. And I have talked this many times in my previous research. And an inner valley forms through erosion induced by tectonic uplift or sea level fall, accompanied by destabilization and landsliding of valley slopes. And Google Earth images before the earthquakes show typical inner valleys along the Minjiang River uh, downstream of Wenchuan. And the riverbed elevation is about 1100, 1150 to 1250 meter, and the elevations of convex slope breaks on the valley side slopes are about 750 to 1900 meter in the area shown in this figure. And we observed the rounded gravels at several edges of gentle slopes in the upper portion above the convex slope break, and so the gentle slopes could be attributable to terrain surfaces, and they terminate in steep, straight slopes below. And there were many roads on the bottom of the Minjiang Valley, and which were uh, hit by debris that came down from the nearby steep slopes of the inner valleys. And this seemed to be the reason why the roads connecting Dujianye and Wenchuan were closed for over half a year. And about the landslide dams, and more than 30 dams formed during the Wenchuan earthquake, and their stability was a great concern. And the stability was apparently controlled by the type of landslide materials and the runout distance. Dams consisting of large blocks of carbonate rocks and sandstone were relatively stable against the seepage and overtopping. But dams composed of finer materials such as some weathered mudstone or phenite were less stable. I think it's easy to understand. And the runout distance also affects the condition of landslide deposits because moving materials would be fractured and disintegrated during the long runout. As the Tangjasan landslide dam was the largest and created a lake more than 6 kilometers long along the river. And the dam has been immediately excavated and drained to avoid a flooding downstream. And after the excavation, a dam cross section was observed, and it was found that most of it consisted of fractured but massive shale rock mass without disintegration. And this is due to the short runout distance of the landslide. And the moving materials sit down just below the source area. If it had run out for long distance, the moving materials would have been disintegrated and become finer. The second Dutch dam was created by the Sabatsan landslide, which occurred on a slope of carbonate rock overlying phenite 55 kilometers northwest of Pingdong, and many other landslide dams formed between Beichuan and Hongbai. So at last, uh, we make we made the conclusions. Firstly, the numerous landslides were induced by the winter earthquakes, mainly along the surface rupture traces of faults and along the Minjiang River. And they were concentrated on the hanging wall of the Lomansha Fault zone and in the valley of the river. And secondly, the carbonate rocks failed most, probably because of their lower shear resistance caused by dissolution of rock along the bathing plains. And thirdly, the dominant landslide movement directions are normal to the fault traces, suggesting the effects of the directivity of seismic waves. And fourthly, the largest volcanic landslide in history in affected area, study area occurred on a calculated slope of carbonate rock with an area of about 7.3 square kilometer and an estimated volume of 0.8 cubic kilometer. And its headscarp coincided with a ridgetop depression, indicating that gravitational slope deformation preceded the landslide. And finally, the very few materials were mobilized at about say 36 sites, probably by poor pressure buildup, and produced a long low bed flow deposits. Okay, this is content of today's class. So next week we will start our regular chapters of this class. Okay, that's it. Bye bye.